You've got on your screen here another conservation of momentum style problem that's a collision. In this case, the two objects don't stick together in the collision. Here we have two carts that undergo a head-on collision, and the question says that after the collision, one of the carts is at rest and the other one is moving. And that's all we know, but we don't know how fast the other one is moving. So step one, identifying the system is pretty easy. The only thing to make note of is that it includes both of the carts, so I have to consider both of them. Now we draw the initial picture, so let's say the carts, let's color code it again. That seemed like it was useful for helping you follow it. Okay, so this one will be going this way. It's a head-on collision, so I'll make the two velocities go towards each other. Let's see, cart number one is 45 kg, so that'll be this guy. And this is moving at 3 meters per second. And the red one is 35 kg. And that's moving at 2 meters per second. Now the final state. So I know that the 45 kg cart, that's the black one, is at rest after the collision. So my final state should be the black cart here with at rest, so V equals 0. And then the red cart, I don't know what it's doing. This is another case where maybe you're not too sure if the red cart is going to the right or to the left. Again, doesn't matter if you have any good intuition about this. Just take a guess. Let's say, I think it's gonna bounce off and go to the right because I don't know how the other one could be at rest if it plowed through. But anyways, it doesn't really matter. Important thing is just that we know what our guess is and we stick with it consistently. Okay. Now I write down the momentum for the initial state. So for the initial state here, you're doing mv for each term. So it's going to be 45 kg times 3 meters per second minus 35 kg times 2 meters per second. So 45 times 3 minus 35 times 2 gives me 65, positive 65. And that's units of kilogram meter per second. And second case down here, final momentum, it's going to be 45 times 0. Of course, something that's not moving doesn't have any momentum. Plus, because I assumed it was going to the right now, 35 times V. So this is just simply going to be positive 35V. Then finally, we set initial momentum equals final momentum. So that gives me 65 equals 35V. So 65 over 35 gives me positive 1.9. The fact that it's positive means that my guess about the direction was correct. And now I also have the speed of the carts. So just systematically apply this procedure step by step, and these are easy.